So I'm Ivan De Prado, I'm the CEO of Datasalt, and I'm going to talk about analytics on ad networks. First of all, I would like to introduce myself. I'm the CEO of Datasalt, and we provide big data consultancy and training in the Hadoop space and in the big data space. We have a lot of experience on that with the big elephant, and during years we have been working in several startups before we found our company, and since we found the company, we have several success stories with these companies. And also we have a deep knowledge on the technologies, as can be shown by our open source products, Pangul and Splout SQL. I'm going to talk today a little about the Splout SQL and how can we use in a real case for ad networks. And also, well, we are in all events that there are around, like NoSQL Matters, Big Data Spain, Hadoop Summit, and we publish some papers on for example, about Pangul. So let's start. The agenda for this presentation is first I'm going to talk about ad networks, about how the market works, about what are the agents that are involved in that market, and I'm going to state which is the needs that they have for analytics. And once we have cleared the problem, I'm going to talk about the solutions that we have found for this particular problem. And this is a solution that involves the combination of two tools, Hadoop plus Splout SQL. Splout SQL is an open source project that we have created. And finally, I will just finish with some conclusions. So let's start by talking about the ad networks market. In ad networks, the principal agents that we can find in that market are advertisers. The advertisers are the people who wants to create campaigns and publish some ads in the different medias, in web pages, in mobile applications. And the publisher is the other side. The publisher is the owner of the medias, or the owner of the web page, or the owner of the mobile applications that wants to place ads on their platform. The ad network, at the end, is a network of agents that mediates between the advertisers and the publishers. It is a network because right now that this market is more mature, we have many different agents on that networks that deals with things like real-time bidding, this kind of thing. So we have things like DSPs, SSPs, DMPs, ADTs, ITDs, whatever. At the end, it's quite complex, this market. So for this reason, we are going to simplify, and we're just going to consider that we have just one agent between advertisers and publishers. So at the end, the ad network is a place where advertisers goes, create their campaigns, and is the place where publishers goes to subscribe to publish their ads in their platforms. In any case, that problem that we are going to think in that monolithical view of ad networks, but that can be the solution we propose. Can be used in the other entities that I talked before. I mean, DSPs, SSPs, because at the end they have the same problem, maybe just a part of the problem, but they have the same problem. Okay, and what are the needs of analytics for this for the ad networks? At the end, the advertisers needs monitoring the campaigns. They need to improve the return of investment of the campaigns. So they need some kind of analytical power that says okay, this campaign was good, was bad, or you paid this amount of money for this amount of impressions or clicks. That was the conversion rate, whatever. Also, publishers needs analytics for knowing what's happening with the ad placement in their medias. They need to know how many ads they publish, which amount of money they are receiving for these ads, and these kind of things. The problem is that there can be tens of thousands of advertisers and even more publishers. So we need an analytical panel for each of them. So it's a big data problem, okay? Which kind of analytics we need for serving these panels? At the end, it's not that difficult. What we have to serve is number of impressions, number of clicks, the cost per click, this kind of statistics, just simple ones. Unique users, these kind of things. For a given range of dates, I'm filtered by other dimensions like campaign, location, language, browser, device, ad type, or any combination of those. That's the kind of analytics we need. Some kind of Google Analytics is what we need. This panel is going to be used in two different ways. There are two kind of profiles we can detect. One is the operational, what we call operational profile. The operational way of using analytics is this kind of use that you use the panel for doing invoicing, accounting, for doing monitoring, this kind of stuff. For these particular cases, the queries that you are running over your analytical system are almost always the same range of dates. For example, complete months or quarters or these kind of things, and always the filters are always more or less the same. For example, I want that for every single advertiser, okay, or for advertiser per location, okay. And what you expect when you are running this kind of analytics is exact results, okay. If you are doing invoicing, you don't want an approximation of the results. You want exactly the number of impressions you have done. The other kind of usage is the exploratory usage. This exploratory usage is the one that you use when you want to discover what is happening, when you want to learn, when you want to for example, you want to see what happened with a campaign in a particular day or a particular range of days for a particular location, for a particular browser, okay? And that means that you need some way of doing ad hoc filtering. So that is different from the operational usage in the sense that you can perform any query that you can imagine. No? And another difference is that in that case, approximated results are okay. Okay, so you don't need the exact results. You just need to know more or less what's happening. Challenges that we face for doing this kind of system. First, the amount of data. We are talking about billions of events per day and hundreds of gigabytes per day. Okay? Obviously, we need a distributed system to deal with that. We cannot use any kind of system that is not distributed. Also, we have to deal with query flexibility because we have to cope with operational profiles and with exploratory profiles, both. Both are different and are in some way conflictive one with each other. Also, we want web latencies because we want to render those panels to the agents in real time. We want the agents, for example, the advertiser or the publisher, we want them to go to a web page and to be able to perform this kind of analytical by some tool like Google Analytics, something similar like that. So we need that the returns to the queries must be in milliseconds. So at the end, what we need is to share thousands of advertisers panels and even more publishers panels. Okay, that's about news. Okay, it's quite difficult. But the good news is that individually each agent can be served with the resources of just one machine, at least by 98% of all the agents. Obviously, always you have 2, 3, or 4 agents that are maybe quite big, because maybe it's a big company or whatever. And maybe in that cases, you have a big amount of information for them, and maybe you have to deal with them in a particular way. Okay? But for the 98% of the problem, you can use horizontal partitioning. Okay? You can split your data in small partitions so that each partition have data from a particular set of agents. So let's talk about our solution, how we solve that. Our solution have this following architecture. As you can see, we have here 2 clusters. The first cluster is the Hadoop cluster, and the second one is the Splout SQL cluster. Splout SQL is our open source database. I will talk later more about that. And what we have here is, we gather the events, the impressions, the clicks, whatever, and we store them in Hadoop. That's a good thing because Hadoop is very good for storing and for computing capabilities. So we use that. And what we do here is that we run 2 different processes. One process, what it's doing is perform some pre-aggregations over the data so that we reduce the amount of data we have, for example, pre-aggregations per day. And also we do some sampling here. What we do is doing sampling per each individual agent, and we store here the samples. Once we have that, what we do is that we run a generation process that creates the structures that we will need to serve data in Splout SQL. Basically, what this process does is that partitions data, in that particular case per agent, so that we know that in the individual partition we have all the data for a set of agents. Those partitions are the files used by a database engine. For this case is SQLite, that is what we are using for Splout SQL right now. And all of that is a process that runs in a batch way. And then we have a Splout SQL. So once we have generated that, we can run a deploy process that deploy all the partitions atomically to our Splout SQL cluster so that we can run SQL queries in the cluster. Okay, so at the end we have two different parts. Here we are doing the sampling and the pre-aggregations, and we are updating the view. And here we have the view of the last execution, and we can run queries here for performing online aggregations and breakdowns and different kind of queries. So let's talk individually for one of these parts. First of all is Hadoop. We use Hadoop. Why? Because it's scalable, so it's very good for storing raw data, the events, and it's also good for their computing capabilities. We can scale perfectly, so if we have more data, it's a question of money. More money, more storage, more computing capabilities. Hadoop is good for creating the pre-computed views and for computing the samples. Also, it's good for generation the samples, but Hadoop is bad for serving data and for performing online aggregations. That's obvious, because Hadoop is not a database. So you cannot use Hadoop for serving data or for performing online aggregations. By the other way, Splout SQL is a distributed database that is able to run SQL queries, unlike NoSQL database that they cannot do. Obviously, with the restriction that you can run only your queries within the same partition. That's the unique restriction you have. Otherwise, you have all the power of SQL because that queries are run on SQLite, as I told before. It's very good for ad hoc aggregations over pre-computed viewers or over the sample data. So you can run, once you have, for example, the day pre-aggregations, you can run the week aggregation online. And it's very good in serving that in a small amount of time, in milliseconds, because you can make the use of indexing and also the use of partitioning, so you can scale. So at the end, we have a well-balanced solutions where Hadoop is offering us some features and Splout the rest of them. Hadoop provides an scalable repository for impressions and a way of performing computations to compute the pre-aggregations and the samplers, and Splout SQL gives us the other part, which is the serving layer. It allows us to serving the data and to compute the final aggregations over the pre-aggregations in an online way. So, okay, now let's talk a little more on detail of how Splout SQL works and how it's designed internally. In any case, you can find much more detail on that in the Splout SQL webpage. That's an open source project that is on internet, and you can just look there to more details, documentation, and some performance metrics. So that's the architecture of Splout SQL. The main important thing here is that Splout SQL is read-only. The unique way to really update Splout SQL is by running a generation process on Hadoop. So we have an isolation between the generation and the serving. That's something very good because we can assure that the serving is not going to be impacted by the updating of data. That allows us to make massive deployment of data. What we do here is that every day or every time you run your batch, we can regenerate all the data, and once we run the deploy, we atomically change the old data by the new data without an impact on the serving layer. So once you have the data on Splout SQL, you can launch queries from your web servers so that you can render your analytical panel in that particular case. So in more detail, that is the architecture of Splout SQL. Here we have the Hadoop cluster. On top we have the Splout SQL cluster. So in the Hadoop cluster we have an API that you can use to generate using data that you have in Hadoop. You can run this process to generate the different partitions that later will be uploaded on the Splout SQL cluster. And once you have the partitions ready, you can deploy them. So you deploy them to a process that we call dnode. The dnode is responsible to answer queries and to deal with the partitions. So we deploy the partitions to the dnode. We also have another processes that are the queue nodes. The queue nodes are the responsible to answer queries from the user and to route queries to the dnodes. So a typical query to an Splout SQL cluster will be you go through a load balancer, you go to a queue node, the queue node sends your query to a particular dnode, the dnode runs the query, and the return goes to user. As I told, those partitions are run by SQLite, but that's something can be changed. We can use another kind of database, another kind of layer. That's something that is pluggable. It's something that for now we have SQLite. The generation phase, we are going to see an example of a generation phase, just a theoretical example. I'm going to simulate what you have to say to Splout SQL to generate a table space. A table space is the same concept than database on databases. And what we are going to say, we have here two tables, and we are going to say, okay, please, Splout generate a table space named T advertisers with two different partitions. And I want to have in that table space two different tables. First, I want the table advertisers partitioned by the column AID, and I also want the table impressions partitioned by AID as well. Once you give that to Splout SQL is going to run a process in Hadoop that is going to generate two different partitions. Each of ones is going to be an SQLite database. And here we have the first partition that have all the advertisers information from U10 to U35, and here we have the rest. Splout is going to take care of trying to make these partitions with the same size. It's something that automatically is done by this system. Here you can see that one property is that all the information for the advertiser U20 is in the same partition. So you can run queries within this partition to get any information for this advertiser. The API for generation is, there are several ways. One is command line from CSV files, for example, and you just have to run the typical Hadoop jar. So you have Hadoop jar, Splout SQL Hadoop jar, and some parameters that you have to configure. Also, you can do that through the Java API. This is the Maven dependency, so you can launch this generation from your code. And in any case, you can import the data from Hive and Pig. So if you have done your pre-aggregations or your computing stuff in Pig on Hive, the final step can be just getting this data and push this data to Splout SQL. So in some way, what you have with Splout SQL is some way of doing materialized views from Hadoop data. Okay, once you have the data generated and once you have deployed it to the cluster, now you want to perform queries. How do you perform queries? At the end, you need three different parameters to perform queries. One is the query, obviously. The second is the table space, the name of the table space. And the third one, and the most important one, is the key. The key is the string that is used to route the query to the particular dnode, to the particular partition. So in this case, we want to ask about the advertiser U20. So that's the reason, because we are providing the key U20, and we want to search in the table space T advertiser. Just by giving these two things, Splout SQL knows that the partition is that. Okay. So now the only thing I have to provide is the SQL query. For example, in this particular case, I'm just getting the name and the sum of the amount for the U20 user, you can see that we are doing a join between two tables. And just by giving that to Splout SQL, the data is the query is going to go to the first partition, and the answer is going to be provided to you. So if instead you will have used the key U20 for getting data for U20, then the query will have to go to the second partition. So how that works? How can you perform queries to the API? There is a REST API, which is very simple. You just have to provide the address of the queue node or the load balancer, and then you just put here these words, and finally you put here the table space, the key, and the SQL query. And the result is just JSON. Okay, it's simple JSON, and you just can create your web application using that. Also, in addition, we have a console that you can use for managing the Splout cluster, but also for performing some queries that always is useful when you want to do some development. Okay, so now we have cleared the architecture, how we combine Hadoop with Splout SQL, what is Splout SQL, and now let's talk about why pre-aggregations and why sampling, and what that means. So remember operational usage. I say that this is the kind of usage that you do for invoicing, monitoring, these kind of things. You need exact results, and at the end, the queries that you run are not that much, and almost all of them have fixed parameters. So for this case, you can do something, and the idea is perform some pre-aggregations of Hadoop, for example, at the level of day or at the level of the delay and location, and then leave the rest of aggregations to be done online on Splout SQL. So, for example, you can perform the aggregations per week using the pre-aggregations per day. Okay, that is the first way of doing, and you can answer why, but why you don't pre-compute everything? So, why are you doing pre-computations and then online computations? And the answer is the following. Imagine that we want to perform all the pre-computations for 2 dimensions, day and location. In that case, we will have to generate 3 tables: day, location, and day. Okay, but okay, for 2 is okay, but imagine that you have n dimensions. In that case, obviously explodes. The amount of data you have to generate is that big that it's impossible to deploy that to any Splout SQL server, and it's impossible at the end. So at the end, you need, that is something similar that happened in OLAP. At the end, the cubes, at the end, the same concept. They decided to pre-compute only one part of the aggregations and then compute other parts just based on the pre-aggregations. So the concept here is similar. Okay, but what happened with exploratory usage? Remember that in exploratory usage, you need to perform ad hoc filtering. So perform queries by whatever combination of dimensions. And that cannot be served by some pre-computations that you have done, because for sure that there will be some queries that is impossible to be served using the pre-computations you have done. In this particular case, you need another approach, and the approach is doing using of sampling. Sampling can provide a good accuracy and fast response. The confidence interval that you can get, so because at the end you need to deal with the precision, is that formula, and it depends on the sample size, obviously, and also in the amount of data that you are counting. If, for example, you are counting clicks or impressions, and the number of impressions is quite low, then the precision is going to be low. But if the amount is very high compared with the sample size, then the results are going to be with a good precision. Okay, so what we do with samples is we create the samples on Hadoop. We create different sample sets. We create, for example, samples for the last X days or for the last year. We have to do that because you have to do zoom dependently on the queries you are going to run. If you are going to run queries, for example, for analyzing the last campaign you have done 3 days ago, obviously you need the sample to be there, because you cannot use the sample for the year to really have a good precision on the last days. And obviously the opposite is also true. You cannot use the the last day's sample to compute something for the year. So at the end, you have to select which samples you are going to pre-compute. And then what you do is just perform online analytics over the samples and extrapolate the results to the full set. For giving some numbers, that is from my laptop, you can scan like 1 million of records per second if you don't catch data on memory, and for a 44 bytes per row. And it can be even faster if you have your data warm in memory, that you can reach 2.7 millions per second. So, okay, but let's talk about the pros and cons on pre-aggregations and open sampling. On pre-aggregation, the advantages obviously are that it have exact results, and it's also that it's good for exploring the long tail. The long tail is these web pages or whatever that you have a small amount of impressions, and that if you are using sampling, you are going to lose. If you want to deal with them, for example, for getting a list of the long tail of these kind of things, you obviously need to go to the pre-aggregations. The limitations, what I told before, is limited to only a set of queries that you have to answer. You have to decide which queries you want to answer, and then you create pre-aggregations for those queries. So at the end, because of that reason, it's not good for exploratory analysis. About the sampling, the advantage is that it's quite fast and provides good accuracy for top-end queries. Top-end queries are those queries that returns you the top-end results, and obviously top-end results have a lot of frequency on the dataset, so the confidence interval is small. But the limitation is that it doesn't work very well if you narrow the dimension filter or if you are looking for things in the long tail. And also another limitation is that the results are approximated. So in conclusion, analytics in ad networks is something difficult because of the amounts of data, because of the amounts of agents, but you can find a solution if you use Hadoop and Splout SQL by the use of partitioning and by using pre-aggregations for operational usage and by using sampling for exploratory profiles. And that's all. So if you have any question.
Yes, please. Here. Sorry, I will take the first question if you don't mind. Can you carry out? I don't know if you mentioned it. Can you carry out full text searches on certain data sets? I mean, some nodes, denodes.
That's something we can do. I mean, it's not implemented, but nothing. It's not difficult to put some Solar server instead of using SQLite. So you can, instead of deploying SQLite, deploying indexes. The unique thing you have to remember here is that the partitioning is the limitation. Okay, if you want, I mean, for this particular case that you are talking, maybe it's better to use something like Elasticsearch or maybe Solar Cloud. But that depends. If you know that the data is constrained to particular clients, it could be implemented.
Okay, sorry.
Do you recommend any open source interface to visualize enter the queries and visualize the data, resulting data?
You mean to doing the visualizations of that?
A front end for your engine.
Yeah, we have just that simple front end, but as you can see, it's just simple for running queries. I cannot recommend nothing particularly. I'm not, but in theory, you can implement drivers to things like Tableau, these kind of things. But we are also working on JDBC driver. There is some driver done, but it's quite simple, and that could be implemented. So if you implement a JDBC driver to that, you can run it using any visualization tool. The unique problem with that is how to auto-detect the key from the query. That's something that not always is possible, because if the key is present in the query, then you can auto-detect it. For example, if you see that the AID equal U20 appears in the query, you know that U20 is the key that you have to use to route the query to the proper denote. But if the query is something where you are doing a join and it's in another table and you say that the value of the column is the value of the ID, then it's impossible to auto-detect. In this particular case, it won't work.
Okay, thank you.
Any other question? Yeah, over there, please, in the upper side.
Hi. My question is, how do you deal with high availability in Splout?
Partitions are replicated, okay? So you can set the replication. You can say, I want to use replication 3, 4, 5. So if one of the denotes disappear, the system continues working. All the coordination is the communication for the coordination is managed by Hasselcast. That is a library for distribute hash. So also the deployment is fail safe. So if, for example, you are doing a deployment and some node disappear, the deployment is success. And we also manage. We have every time you deploy a table space, you have a version number for this table space, so you can do rollback to the old table space. In case something went wrong, you can do in rollback. You can also do deploys of several table space at the same time. So you don't give. So both of them are going to be present and ready at the same time.
Okay, but so the data is replicated or not?
Yeah, data is replicated.
Okay.
Please say your name before you ask your question.
Thank you, Ivan. My name is Federico. What is the advantage that you use Splout than of another competitive solution like MongoDB?
Okay, in MongoDB, you can perform some aggregations, but I think that's something limited in some way, right? Also, the problem with the MongoDB is that you see here what we do. Well, okay, I don't have it, but when you are doing analytics, sometimes the data changes from one day to the other completely. Sometimes not. That depends. But we are able to deploy new kind of data from one day to other, and it's something that is not painful. In the case of MongoDB, you have to, for example, having a particular schema or a particular indexes in advance, and at the end you will have to deal with the system only using MongoDB with Hadoop, I think. Well, in any case, you could do as well with MongoDB.
Hello, good morning. My
Hello.
name is Javier Lopez. My question is about the business side. I mean, you are dealing here with question about what has happened with my data, with my impressions for this advertiser or whatever. Do you have done anything about deciding the best place for an advertisement? For example, if it's a good target for me, I mean, kinds like real-time bidding.
Well, right now, we have not done things like that. We are working right now with several clients where we are dealing with things like segmentation of clients based on their behavior and based on how they see ads and this kind of things. So that system is going to, in some way, use this data to improve real-time bidding. So when you do real-time bidding, you can know better which is the profile of the user that is using this web page. Okay, so it's something that we are doing, but it's not related with the analytical thing. It's something that can be done in Hadoop.
Sorry, so it's another question about that is what was the best technique or the best way to do that? I mean, I suppose sampling, of course. But
No,
if you are talking about Hadoop?
No, because remember that this particular architecture that I'm describing is because you want to create analytical panels that gives response in real time to the user of the panel. But if you are dealing with this amount of data, the proper way of doing it is just running things on Hadoop. For for example, using Hive with a Stinger, or using Impala, or using just Hive, or at the end, the better way of approaching that is just having all the data in your cluster and running these kind of queries for machine learning, for learning what you need to learn.
Thank you.
Hello. Had you said the response time is important in this use case?
Mm-hmm.
Did you try solutions like memory grid distribution of data, like coherence, like Hazelcast?
Mm-hmm. Well, Hazelcast you can distribute the data, but we will lose all the power of the SQL or something query language where you can get aggregations easily. For example, the other that you mentioned, I don't know, but for sure that there are solutions like, for example, SAP HANA that probably will have done a good work here. We are using a SQLite for the engine, but we could change that. We are thinking that maybe in the future we are going to implement our own engine that is running just in memory, okay, or using some columnar format plus in memory plus things like Alan Getz has said, like the vectorization of things to get in even faster speeds. No? Right now, with the SQLite is a good start.
Okay, anybody else? Before we run to the lunch break? No? Okay. So, Ivan, thank you very much. Very interesting.
Mm-hmm.